for this next section, we are going to have Francesco. We didn't met through the coding, the open source, but actually we met through our hobby.
The evil part of
hobby that is we were when we were young.
Yeah.
We were doing caving, okay, deep caving and so on.
Yeah.
And actually, he was the first one to introduce you have to learn Linux. What is Linux? I was in my 20s.
All right.
And from there, I didn't come back. Okay. And Francesco, as I mentioned, has been through a big help in really in the beginning of the packaging the GIS Debian. So where then later on Ubuntu take all the packaging and so on. So apart from the geocomputation that I think he does for fun, and then the packaging he does for work. So I think you can bump him of question and so on. So the floor to you for the Google Earth Engine interface in Python.
Okay, so
and like always, enter in the SD data and do another.
So my idea about this presentation is even two parts. One about Earth Engine API in general. The most natural one is based on JavaScript, and then we will see how it is possible to perform almost the same things via Python API and using some auxiliary packages to do the same thing. In order to use, let's start with the browser. In order to use Earth Engine, you need a Google account, and also you need to ask for authorization to the use of the code editor and the Google Earth Engine to Google. This is this joining needs to be done the first time you need to start up with the code editor. So now in this session, I never asked for this. Hopefully, all things will go. Let's see. Okay. Oh, recently, most of the accounts in Google needs the 2FA, the two-factor authentication, and this will need to be used also even for Earth Engine, and also when we will use the Python interface. So in order to do this thing, there are different ways to authorize. Let's use the easiest, which is SMS message. Okay. So what is the Earth Engine? Earth Engine is a sort of Google Maps with steroids. That means that you can use exactly the same thing. I think most of you have some experience with the Earth Engine. I hope so. Someone maybe not. But what you find in Earth Engine are essentially the possibility to perform a series of processing on remote sensing data, and also geospatial information in general. And the other thing is the possibility to dive in a big archive of data, of geospatial data. Currently, I think it is about 70 petabytes of data, and it's growing because all satellites that provide that provide information to also to Google Earth Engine continuously release data. This is of course true for Landsat as well as for Copernicus Sentinel satellites. So this archive is continuously growing. Why Google Maps on steroids? Because you have essentially at first glance exactly the same thing, that is the access to Google Maps account, Google Maps data, but also you have the possibility to use a series of processing and algorithms. This is the so-called code editor, which is composed of 4 different views. One is this one, where you can have a look to Google Maps and other data superimposed on the interface. The other is, of course, the catalog of your scripts and possibly also of other people's scripts, as in this case. So this is first of all a way to share also scripts among people. All people that have an account or credentials to access Earth Engine can share with other people all their scripts in read or write mode. So it is possible to have an account, a shared work among groups, among teams, in a very easy way. The only thing that is required is having Google credentials. Currently, there are no costs behind the Earth Engine interface, no cost behind the access to the catalog, to data catalog, and no cost due to processing types, for instance. In reality, there are some limitation in use. For instance, all of you, all people with Google credentials have access to Drive. And the Google Drive is the way to exchange data with Earth Engine. So all data that are not part of the catalog of Earth Engine needs to, in some way, to be imported or exported. And we have basically 2 ways to do these things. That is using the Google Drive, and you know that for free you have for all your services 15 gigabytes of space. The other way to share with Earth Engine data are using the so-called assets. The assets as another quota for all users. They start from 250 gigabytes of space. This is the basis for all. Of course, there are other quotas that are not so immediate and visible to the final user. And this is based on the fact that when you run a process in Google Earth Engine, you need to cope with limitation on the time slice for processing. This is not immediately visible in Earth Engine, but for all users, it's a common experience that scripts that never complete due to, for instance, the excess in computation time. And so in those cases, the scripts are simply interrupted by the services. And of course, the user needs to find a way to cope with this kind of operations that are quite long to perform. In some cases, for most cases, for important operation, for important processing, they could be also arranged with Google people. So very common, well-known experiments in the past, like for the monitoring of deforestation all over the world, in a well-known paper of some years ago, were arranged with Google people in order to perform all operations. So now let me start with some note about this one. Some general note about the data model. All those slides are commonly available on Google. So I will use just to explain some of the basics of Earth Engine. So this is of course, the common data editor. I said that there's a JavaScript API and a Python API. So behind the code editor and behind the Google Earth Engine, there are a cluster of computer servers that run Node.js. So even the backend processing is done in JavaScript in Earth Engine. This is not immediately visible to the users, but all the work is done exactly in the same way. That is, each browser runs its own JavaScript client to perform to run scripts for the user, but also the backend of the Earth Engine system run Node.js, so JavaScript to perform operations on an HPC or an HTC high throughput cluster, whose composition is not currently known. We don't know how many nodes and how many cores run behind Earth Engine. For sure, they are a lot, but I don't know, and nobody knows exactly how many cores are used on this system. The Python module is provided again by Google, and on top of that, it is possible to run a series of scripts, or a series of packages, sorry, for Python, and get almost the same results in comparison with the code editor. Some difference we will see in interfacing, because the big sorry, not me. The big difference among the JavaScript and the Python APIs is in the user interface. So while the user interface is fully integrated with the JavaScript code editor, this is not the same for the Python API. So in general, the user need to arrange for the visualization using different packages, which could be the matplotlib, even also the plot packages and so on, in order to get the same results that are commonly available within the code editor. But it's perfectly possible to use them. We will see an alternative way to do the same thing. It is also now possible to use notebooks or Jupyter to run Earth Engine scripts without problems. So this is quite a quite old evaluation of the public data catalog. It includes essentially all the public domain open data catalog of satellites. So starting from Landsat to MODIS, Sentinel constellations, and many others. Of course, also other common used data such as digital elevation via SLTM, surface temperature, land covers, and so on. The data sets are fully available and increasing during the time. Now, about the data model, of course, the Earth Engine works with raster and vector data. In terms of Earth Engine, the terms used by Earth Engine are feature for vectors, and raster, and the images and image collections for images for raster. An image is, of course, the same that we can imagine. That is the stack of multi-band image rasters with a lot of metadata, such as acquisition date, type of bands, and fully auxiliary information, such as the cloud coverage and so on. Of course, each of those images have their own native resolution information, but this is secondary within the workflow of Earth Engine, and I will explain in what sense. Another important item in Earth Engine are the collection. The image collection are a bag of elements, a bag of rasters, and they are collected all together. And a collection is generally correspondent to a full set of all available images for a specific satellite and type of image. So when you think to an image collection, you have to think, for instance, to the full data set of Landsat 4, 5, 7, 8, 9, or whatever. You can think to an image collection like as a directory of images. The full image collection contains all the available images worldwide, with worldwide extent. Of course, these giant collections need to be in some way managed in order to extract only the information required for performing processing. While it is in principle possible to run a process on a full data set of, for instance, Landsat images, this is of course not practical because the processing could never finish. So user needs to filter, sort, and manage, extract part of those information, possibly in some area of the world or the globe, and perform some of the common defined pattern of processing. For instance, Peter talked about the map and the reduce concept. The map is a common pattern, programming pattern, design pattern, because when you perform a map over an image collection, you are performing for all pixels of all bands of all images within the collection an elementary operation, which could be, for instance, the multiplication of the pixel for the pixel value for instance, for 2, for 4, for 10, or what else. Each of these map operation produces a stack with the same dimension of the input image collection. So the map is a many-to-many operation. You start with an image, a full image collection, eventually selected, so with specialization for finding a subset of images, and then perform for each of these images, for each of the pixels, the same operation in full resolution potentially. Another operation instead is the reduce operation. The reduce operation takes the same image collection and summarize characteristics. So a typical operation could be finding the average value for each pixel of each band of each image of the collection. And so extracting a single or a mosaic of images or a single image with value for the average value for each pixel for all bands. This operation is a reduction because it changes the cardinality of the image collection. And so you change from the full stack to a reduced stack of a few bands or one just band in this case. Of course, each of these operations, the map and the reduce, can be conducted on regions. So you can decide to apply the same operation of map and reducing only on subset, spatial subset of the image collection. These are some example of the reducers that are the main operation that you perform on the image in Earth Engine. So you're starting from a very simple operation up to operation that are filter, regression, and many others operation, which can be conducted on the function, on the collection. So yes, this is just an example of a reducing operation. Of course, when you reduce an image collection, all this stand on a full collection, but one of the operations performed is the mosaicing of the collection. That's because generally the collection contains images that are that have different extension on the globe. So the final results for the reduce operation is a mosaic of the image collection, of the starting image collection. Operation includes of course also reduce performed with regions and windows. So simply some results. And of course, all can be done by region said and obtaining those results. The concept of filtering is expressed in this kind of operation. So you perform step by step, start from a Landsat image collection, you filter by date in order to reduce the size of the collection to perform operation, then move to select by image data. So for instance, your choice is extracted surface reflectance. Then you can apply a common operation such as NDVI index operation, which can apply to a couple of bands in the image collection. The result is a composite of images where you can extract the NDVI index, for instance, getting just one final result. So you get you can get both a composite resolution visualization and an NDVI operation. So you can visualize and also process the image and show both the bands in this is the visible RGB visualization. Also perform operation in DVI, and then you can also choose a scale of representation. In this case, 30 meters, which is the native resolution. The timing we will show, of course, each image is as in the case of PyGeo, also in Earth collection, all operations are done by pre-tiling. So each image collection and each image in the collection are tiled, and each of this tile is processed by a different core, a different CPU. Of course, all this is possible because each of the image in the image collection have multiple representation on the basis of the available resolution. So even if you have a Landsat image at the natural, at the native resolution of 30 meters, the Earth Engine catalog contains also all intermediate resolution. So you will have all possible representation of the images, also not at 30 meters, but also to all available zoom level in the system. Exactly like like it happens in Google Maps. All those operations are conducted at native or at required resolutions on the basis of the will of the users. Let's see some basic script. So first of all, JavaScript, is it visible enough? Or I have to Okay, better. First of all, JavaScript is a quite simple language at first glance. You can see here a comment, a single line comment, a multi-line comment, a definition of a variable like this, the string var. String variable can be introduced by single quote or double quote. It's perfectly the same thing. Here you can see how the code editor is can be used to give evidence to errors. In this case, you can't use a reserved word like this as for a variable, so you can fix on fly the error in syntaxes. You can use semicolon or not, because JavaScript can be used with or without semicolon at the end of the line. The syntax is case sensitive, so if I run, clicking here, this simple script, it shows that another is the wrong variable. You can run again and get the result. When you run something in this in the console, appears both the errors for syntax and what else, but also any representation like this can be used for any other object. In this case, we have not other variable, but it's always the same. Now, generally, the image and the image collection could be introduced by looking at the data catalog. The data catalog is visible in the Explorer, which is part of the Earth engine. You can search here both places and image collections. So for instance, for each of them, the Explorer provides information about the type of data. Each of them are anyway available with all required information. Here, when a single data collection is visualized, also is visible the ID of the image collection. The ID is used to point the data collection and have the visibility within the scale. Yeah, for instance, we had this RTM, and the answer was the type of deforestation experiment I said previously. If I run this one, this simple script, you can see that the script loads in the map map area two layers. One is as SRTM, so the dam, and the other is the loss of forest in the which is a available layer in the data catalog. The forest change in this edition. 2000 versus 2016. This is deprecated because there are newer layers available with the same within the same workflow for Hansen experiment, successive to 2016. This is, of course, a mask. So it is where does the forest has been lost. There's a point where the forest is not present or not available. There's a black, so there's a null point. These two variables are available with all the data bands, with all the meta information available. And you use this function, which are part of the Earth Engine API, to visualize, in this case, the layer available. In this case, you add to the map a layer as RTM, then forest, give them some information about the specific color table to be used, with a name, which is something you see reported here in the layers list. And the two layers are visualized stacked. So when you visualize each of them, you can sort on the basis of your will, of your intention for visualization. Each of these layers can also be manipulated for the visualization after the visualization, changing, for instance, the range and stretching parameters for the color. You can change opacity and so on. So even the gamma, or use the palette to change the color to be used. Of course, one can also use the masked loss as a proper mask. And so visualize in a red palette the loss overimpose the other layers. Again, stacked or not. This could be a proper way to visualize the masked, the loss of forest masked over the SRTM. Just another example could be this one. Here again, I'm visualizing SRTM, and one can use a simple decision tree to visualize different colors for different elevation in the model SRTM. Again, the palette can be expressed by using this very simple list. At this stage, at this level, the syntax of JavaScript is not so different in respect with the Python syntax. Can be used in a very simple way. What I can stress is the use of object-oriented pattern for syntaxes. So this is a typical example because you have an object created by the image creation method. This method creates an empty raster. And then where the elevation is greater than 200, then 400s and 600s, the mask is updated for the elevation, and then the different mask here used can be used to show different colors by applying this palette. Okay, min and max are the range, the maximum range used for the SRTM. And this zoom creation is done simply by calling this kind of procedure. About this script, one thing to understand is that the computing by Earth Engine is done at visualization level. So what could be called an on-demand visualization by resolution. Indeed, the resolution of the native resolution, SRTM, is 30 meters, but the computance is not done at 30 meters. It's too fast to be conducted at native resolution. It's conducted at zoom level. So when you perform any operation in Earth Engine, it is not done at native level, at native resolution. It is done at visualization resolution. That's the reason why most of the operation in Earth Engine seems so fast. It is an illusion because it is subsampled. So you are not really seeing the final result of a very simple operation like this for all the globe. It is only done at a very low resolution, which is the visualization level resolution. You know that maps is quantized for resolutions. So it moves from the native to quadratically changes the resolution up to a maximum level. So there are specific little number of pre-computer levels. They are not more than 15 levels. Each time you change the visualization level, again, the image collection visualized or computed changes the details because they are subsampled again, and this is the final result. So each time you perform an operation in Earth Engine, the reality is that you are doing only operation on a subsample of the catalog, not at a native resolution.
Of course, you can force.
You can force. This is specifically evident. There's a little inconsistency in some operation of Earth Engine. I mean, in some cases, some of the arguments, some of the method needs to be provided with a specific level of resolution to be used. Some of this operation needs to be performed by specifying the resolution to be used. This is generally done specifying the native one, but it is not always the same. Some of those procedures, some of those methods, it gives the possibility to specify the sampling, that is the level of or the number of meters used for the resolution. Some other not. In general, this is not specified. Some of this operation needs to be done specifying this kind of information, and even specifying the SRS, the spatial the representation system to be used. That's because, for instance, operation like this one, the exporting, needs to be done by specifying the scale. Exporting is one of the common operations used for taking the information, taking any layer, any image available, and exporting in a common GeoTIFF format. This needs to be done by specifying explicitly the scale to be used. That is the number of meters for the resolution, the final resolution. The SRS, I mean, that used here in the maps. So all the data are generally projected in pseudo-Mercator. That is the spatial projection used in maps. All data are generally projected in this pseudo-Mercator projection, and not in a native, for instance, in the native WGS84 or what else, UTM or what else. So when you specify the exporting, in this case to Google Drive, you need to specify the scale and the CRS. In this case, the common WGS84 ellipsoidic project and system of coordinates. This is one of the cases where the system cannot guess what the user want to be done. It is something that needs to be specified explicitly. Another thing that need to be done in these cases are also the specification of, which is not the case anyway, of what is the output of the exporting data, of the exporting batch. While most of the operation in Earth Engine are conducted in visual manner, on demand, some of those operations are instead in batch mode. The exporting is one of them. When the exporting is run, typically the system prepare a task, a batch task that needs to be run apart, and the user needs to wait for the completion. One has to explicitly confirm the scale, the coordinate reference system, the task name, and also eventually the file name to be used and its format. Generally, the most common is DIRTIFF. The run is started, and this operation proceeds for whatever time is required to complete the operation. In some cases, it could fail. Specifically, it could fail when the exporting operations are very large. So, for instance, it's almost impossible to export anything from the Earth Engine if it's too large for the processing time for the duration of the operation. So generally, exporting data from Earth Engine needs to be conducted by little tiles, never at full range, because it is impossible to complete any exporting operation. And this is a general rule. Note that the batch mode, the task is still running now, and it will complete in some time. Eventually, it could never complete. And so the user needs to be prepared to find another way to perform the same operation. So, for instance, avoid exporting. This is a quite common pattern in a design pattern in Earth Engine. You need to find alternative ways to perform the same thing. Because in Santa now it's finished, and you have the final result should be available in Drive. Not here. This one. And this is the result. And you can, of course, export and pass to other process. This is another type of information. One of the things to do generally is fixing some a reference point in order to run scripts in specific areas of the globe. That's because the processing is again visualization is linked to the visualization area. So when you need to visualize, in this case, the NDVI, you need to perform that in a specific areas by fixing the geometry. And so in this case specifically, you see the image collection selection at work. In this case, the image collection that is that of Landsat 8. This is the ID of the Landsat of the image collection. You filter by date using 1 year. Then if you use the filter bounds in order to select a specific geometry, which is this point. Specifically, the script center the geometry as and the scale level at 11 in order to visualize. All the script is conducted at level 11 and in this geometry area. So it works quite fast because it's not working for the whole globe. If I change the zoom level, you note immediately that the time changes. In this case, I note that I selected by filtering per geometry. So in this case, the geometry changed because I removed all images that are not centered on this point. The whole data set of the Landsat is reduced to the few images in this period from 2016 and 2017 that are centered on this point of geometry. So only the images that intersect this point are part of the collection I'm interested in. All the other are filtered out. Here we see a function. Peter called this type of function a callback. Indeed, the callback is the standard way to perform operation on image collection by Earth Engine. This function is used during map operation, like in this case. This is a map operation, map processing, where the callback function is this anonymous function, which computes the normalized difference, again, the NDVI, by using a pair of different bands in the Landsat collection. Rename the resulting layer in NDVI and return the resulting band. So at this point, max NDVI contains the NDVI object, which is again a subcollection. NDVI max is a reducer operation because changes starting from an image collection, the max extract the maximum for each pixel, and so you get a single band which is visible because it's a single image within the map area. So we perform a map first and a reduce after. In this case, the reduce operation is simply the maximum. Both them works on input for using an input from an image collection, which is in this case is quite reduced. The result of the reduce operation is a single layer. It's a single raster. Okay. All this is quite fast because I filter all worldwide images by using this geometry. So most of the operations that are conducted in the Earth Engine are not conducted worldwide, but only on specific areas by using a filtering bound in order to avoid to perform complex operation on area too large for the processing time. Another interesting function used in this case is the possibility of charting this one. In this case, this UE chart image the Y series extract from the NDVI and present the value of the NDVI during the time. So in this case, we use the maximum for NDVI. But this collection is a multi-time collection. So you can perform during the extraction of the same image, of the same data, the same collection of images for each day of the year. And in the point where we are interested in the value, which is again the value of the image collection of the whole area extracted, we can perform the mean of the NDVI and simply chart the value of the NDVI along the year. So this is the possibility to avoid exporting information. You can use the chart operation in order to extract your information by allowing the computation of the NDVI, the medium, the average NDVI on a long series of images directly within the Earth Engine console and cluster without exporting anything. Using the chart is the possibility to avoid computation that are performed off of Earth Engine. Another typical operation which can be performed is the zonal statistics. Again, the same pattern. You choose a geometry, a single point. You choose again a Landsat collection. You filter by geometry. You filter by data. In this case, this is again Landsat 8. You use again the same pattern, that is the callback function to compute the NDVI index for the image collection. In this case, you use a filter to mask all values that are off, that are less than 0.7 for the 0.7 for the NDVI, and then perform operation only on a region. In this case, the region is that of a buffer of 50,000 meters, centered against the geometry. Okay, in this case, so I'm drawing in this case the value of the max NDVI, the region where that is the buffering, and this is the resulting filter applied by using 0.7 as a threshold. Yeah, it's also again I'm creating the zones for each of the elevation. Again, with the clipping for the region, the buffering region, and the multiple layers so obtained are then are drawn on the map. with the with the dimensions of each of the region, the sum of the pixel. Again, here a scale is used, and note that also a max pixels keyword is used. That's because some of the operation in Earth Engine are limited to a certain number of pixels. The default one could be quite limited. In some cases, you need to force the number of maximum pixels to compute, to force them to be computed. Also, this is the only way to perform some operation, because the default one could be quite low. So in some cases, these limits need to be forced, else you get an error. In this case, if you try to comment and run again, that should fail, like this one. This is a typical results for Earth Engine. When the pixels for the region are too many, the operation fails. So you need to force, as in this case. So this strange parameter. This is not always possible. There is a possibility to force a computation by specifying max pixel number. But sometimes this number cannot be augmented to any level. You need a superior threshold. In those cases, the operation fails, and there's no way to work around. You need again to find another way to perform the same operations. For instance, in this case, one could change the scale. This implies that the scale of computation is 30 meters. One can increase this value and so perform the same computation at 100 meters, at 500 meters, and so on. There are other ways to perform the same thing, but for arranging with Google for the operations, which can be done, but you need to wait for answer and discuss and be prepared to discuss with Google folks about the opportunity of performing some operation. That's because the resources are limited. So it is not always possible to perform such operations. Now try something like something like this, just to show another more complex example, and then we will move to the use of Python and try to perform the same operation by using the Python API. So this is, for instance, a simple experiment. Let's try to run it. This is quite more elaborated, more complicated. So one has today is St. Anthony, so the center of this experiment is in Padua. It's computing multiple layers. Earth Engine is possible, but this is not so fast, as you can see.
Francesco, and so in terms of processing, there are quota for processing and also for storing data, of course.
For storing data, yes, there are quotas for drive, quota for assets. I already said about talk about the 250 for assets. The assets are what you can load here in this area. You can add your own assets, this is your own data on the system, and use with your with all your other data. You could upload area of interest. You can upload other information, also other data, such as commercial satellite data that are visible only to you for sure, and any other kind of information. But you have to limit your asset area to 250 gigabytes. But for that, there is the limitation for the Google Drive, because if you need to export information, to export layers, you need to stay in the 15 gigabytes that are for the whole accounts. So includes mails and so on. In practice, this could be limited to very few gigabytes of space for exporting. About the computation, one of the limits is due to the number of pixels for computation. So for some operation, already said that it is possible that there is a limitation for the number of pixels to be considered. This can be forced, but the change of the number of pixels can be done in the operation, but up to a certain level. It depends on the operation. It's not something fixed. You can work with 1 million, with I say 1 million pixels, not more than 1 million. Or if you force, you can arrive to you can reach the limit of 10 millions, but not more than 10 millions. All this can be arranged with Google Force anyway, because of course the limitation, the quotas in processing time are per user. So it's something that can be arranged for specific cases. So let's see this set of Google collection without specific. This is a very simple application where one is interested in finding the changes in urban settlements. During a certain period of time. So this is a comparison between the urban areas in the area of Padua in 2019 against the 80s. So there are two different collections here. One is this one. So Landsat 8, the period is the year 2019. The other is Landsat 4 with a period of from 1988 to 1991, so a period of 3 years. The need of changing the range is due to the time frequency of repetition for the visit of Landsat, which increased for Landsat 8, but at the time of Landsat 4, it was quite small for the area of Italy. The first versions of Landsat, the first releases of Landsat were quite USA centric. So most of the world was not fully seen from the Landsat satellite until the recent times. So the needs for using 3 years versus 1 year. Of course, this period is masked for the cloud, and this used also the median and also the clipping around the area of interest in order to extract what kind of images. The images here shown are for instance, this one. Whoops, it's a long list. So, for instance, this is an image at true color, so in RGB. In RGB, this is the same image again, it's the median in false color. In this case, the near infrared is used to give evidence to the vegetation area. You can see that most of the area, the urban area, of course, has a low, is not red, because the near infrared is loaded on the R or on the R band to give evidence to the vegetation. The same for Landsat 4, and you can see how the area changed. So there's an increase in you can also see in true color. Sorry, that's not this one. There's an evidence of change in the urban coverage. Then both layers are classified by using the data here. So fourth class of coverage has been introduced. That is water, vegetation, urban areas, and they are used for perform a classification on Landsat 4 and Landsat 8. The classification is performed by using a random forest. This is for Landsat 8, and this is for Landsat 4. Of course, the same resolution is used for both the satellites, and then essentially a difference among the class for the urban class is performed. So the black areas are changes where some classes changed in urban, starting from whatever. So from vegetation or from green areas. To be confident with this kind of results, also the GHSL is shown. This is one of the data sets available in Earth Engine. That is the global human settlement layers available in different dates. The recent one is the 2015. This is a sort of again a mask. And show then the result of the coherence of the settlements with the classification. And indeed, if you have a look here, I remember, yeah, right. And also, but for classification, also accuracy is by means of confusion matrices is computed by finding an accuracy of 94, almost 95% for Landsat 4. Maybe the same for Landsat 8. This is the confusion matrix. Maybe there is no print. That's not the print for the overall accuracy for Landsat 8, but are comparable in a way. And also there is some computation for the area, the surface of the new urban area in squared kilometers, 44 kilometers. For Landsat 8 and Landsat for the new urban area. So for the difference among the Landsat 4 and Landsat 8 classifications. Let's see the script. So here, this is the classifier. The input training starts with 30 trees for the random forest, which is quite acceptable as a settlement and as a setting. This is for the bands. Oh yes, this is for use of the cloud shadow and the quality. And the quality of the pixel. So, for instance, the Landsat satellite, among the information, the metadata, report also the quality pixel. So one can filter also for the cloud mask and for the quality of the pixel in order to select only images that are quite good for classification. And this is what is done. The same for the vegetation. Landsat 4. Oh yes, for instance, for people that you already used Earth Engine in the past, one thing to have present is that sometimes the API changes. The API changes and some methods become obsoleted and other becomes new methods and are available. So it's quite common that old scripts could become not runnable on current version of Earth Engine. This is the case, for instance, for this script, where random forest has become another algorithm, has changed the algorithm. There are different classifiers within available in Earth Engine, and the change in API needs to be taken in consideration because the script needs to use the current versions, the current API version, and the current function available, not oldest one. Okay, this is just for giving a practical example of a script like this one, with the possibility of running and filtering by different criteria. One final thing to consider in using Earth Engine is always that when you run your scripts, the scripts are always client-side, but the data are server-side. So sometimes you need to perform some tricky operation in order to work to cope with this remote centric operations. That's because sometimes when you write a script, could happen that when you use variables that are valid only for the client side and not for the remote side. So you should always consider that the variables used within the script needs to be always handled for something remote, never local variable. Local variable used within the script can be used very, I would say, sparsely, but only for specific purposes, for very specific purposes. Most of the operation needs to be always remote-centric and use handle that are the special variable like the image collection, the image or the array and the other object of this type, because they are completely different from generic variables of the JavaScript language used within the script. Those aspects cannot be confused, or else the scripts tend to fail miserably because of the confusion between the local and the remote side in the script. Never you should use, I would say, local variables, or for instance, use some loop in with fixed run on local variables. And so index based on local variables and so on, because they do not work within the script. Okay.
So your daily working environment. So when you use Google App Engine, I mean, you save the imputation for G Drive and also the processing. So how you deal? Do you have special account? Do you buy storage? When we see these big projects,
generally we use for tentative algorithms. So never for full production based on some very intensive computation. We use, at least for us, we use Earth Engine to explore in a fast way the analysis of some algorithms or some analysis of data, because you have all those data immediately available on the catalog. This is the main purpose for us for Earth Engine. When you have to perform an intensive operation, it can be done, but it needs to be done completely on remote side. If you start with the idea that no, I need to export something and then process with another tool and explore part of the results of big rasters and what else with other tool, because you have not the possibility to use a function that you could find useful, that's the wrong way to go. You need to use and be you should find that the Earth Engine function should be enough for you. If the available algorithm, the available processing strategies are not usable for your purposes, that's the wrong way to go. Trying to export and re-import and so on is the wrong way. You cannot try to do that. So in this case, you can simply use charting and what else, or a specific set of area of interest points for finding classification and so on. Also intensive vector data are always small for sizes, can be used to explore your arguments and find results, but never to explore at a large scale. This for our purposes.
And, I mean, when we see this article that they've been done everything with Google, probably they have
it is all yes. So there's always some agreement. Often there's an agreement where the final result is going to be part of the catalog, like in the Hansen case.
Yeah.
So it is a well-known results by paper That was what published on Nature,
Yeah.
remember? So they are interested in giving back those information to Google, and so they arrange for those kind of things. Of course, it's like sort of grant.
Yeah, yeah, yeah.
It's not different.
Because of course, then they will have processing time.
Yeah.
And
Yeah.
also space.
Exactly.
Okay.
So let's try to use the Python interface. I find that some that we need to I don't know the reason, because I explored that in this today, but for some reason we are the package I'm going to use, it's not working, are not working under 3.8 for Python. We need 3.9. So I find convenient to use Miniconda in order to install the right version. Let me see, where is this one? So in order to use the Python API, you need a few things. First of all, you need to install the Google Cloud command line tool, which can be done by adding on the, at least on SGOLib, on the Debian or Ubuntu distros, a few packages, and adding essentially a repository from Google just to install the Google Cloud. If you do not do this thing, you can find something like this. You can eventually do this. It means Earth Engine, which is the easy part. But if you first of all, you find this problem, because 3.8 is not the good version. So Miniconda is a quite tiny version of Python distribution. You can install also on Linux, on Mac OS, on Windows, on anything. Within Miniconda, you have a virtual environment, which is alternative to the Jupyter Lab environment you used until now. To install, just run this one. Right. Accept the license. It installed within a directory Miniconda 3 under home user. It's quite fast.
Is this summarized in this webpage?
Yeah, yes. It is all always is here in here, and also in the Miniconda homepage, official documentation. That's not nothing. This is present on where is this page? There's oh yeah, there's yes, I'm using this URL. Let me say this one.
So, yeah. So that URL is that page.
Okay. It's a sort of circular dependency, because to have a look to this stuff, you need to have the Jupyter working. But to have Jupyter working for this stuff, you need to have all this installed. So this is for installation of Miniconda. Then you need to install the Google Cloud Common Language Interface. Just
But I'm
line by line.
okay. So this is okay.
This is a bit long, but we need to, yes, and we need to complete with the other line. I think this is this one. Okay,
So be careful. Go back.
yes.
Go back to the. Be careful. This is the full line.
Oh, no, yes, this is full because there's the end of
okay.
line here.
So these are the same line.
Yeah. Yes, that's see, no, it's not visible. No, but, okay. And now this should work. Here, you see that there is the repository for cloud, for Google Cloud. Now I need to install Conda. Note that we installed Conda, but need to create the environment, which is done by simply use activate in Python 3.9. When it first finished. Conda is a nice environment to run Python. It always works until it does not work. Because, you know, using Python is quite tricky due to the use of multiple versions and the use of multiple versions of multiple packages. So the combination of all those things sometimes is quite tricky, could be quite tricky, and could result in strange outcomes. So one has to be prepared to manage things in a bit different way on the basis of the packages. So for instance, I'm going to use packages that are available under 3.9, but if your distribution is based on another version, you could have some problem. The good part of the Anaconda is that it is a whole comprehensive distribution with multiple versions of Python available. You can activate any one of them, multiple version of packages. And most of the extensions are already pre-built with the right version of the Python version, and also available packages can be switched by using virtual environments and multiple version of Python without big problems. Now we have a bit patient to complete. Faster.
Speak. Who has been using Google Assistant?
Yes, for sure. Many experiences now. One, two. Did you find useful?
Yes, it's not complicated.
Yeah. We find it very clear for not engineers. So we have a bunch of geologists and so on that find much more usable Earth Engine than any other solutions for obvious reasons, that you have not to cope with petabytes of information or the data in multiple formats, and or have to cope with tiling and with the limits of memory and strange and tricky syntaxes with the exotic languages and so on. Okay, this is finished. Why content not found? All right, maybe you have to, sorry, you have to exit and re-enter. I hope so. Not add. Installed conda, yes. Data PK. Yeah. Maybe I didn't activate. Strange. Okay. So this was one of the. Generally, one has to add it to Basher RC, but for some reason didn't add the entry. And we were here. So, okay. Conda activate and install there that. Create. Right. Something missing. Oh, sorry, this one. It's missing. Generate adds something to some line to the Basher RC, but in this case, probably the presence of the previous environment, Jupyter Lab probably disabled this possibility for some reason. Generally, after the running of the Minicon installation, it asked for adding the required lines to the bash RC. In this case, seems not. Anyway, so on this one, activate GUI. So can go here. Sorry, the wrong one. So we have to install GeoPandas and a few other things. Let's try with a single copy and paste. Let's try all together. If the command install phase for some reason, one could revert to pip install after activating the environment, or also trying to install directly by setup when required. At least under count the problem. This is for Peter. At least under Conda, generally the problem of managing the system-wide packages for Python is correctly managed. So you can inherit from the system all existing packages within the Conda. It is your choice. You can set up.
When you create the Conda environment, you have to take that in advance.
The default is getting the existing packages. In my case, when I tried, the problem was with Python version, which is a main issue.
Yeah.
You should use one version of Python, and then you can get the right version for the right edition of the additional packages from the system, but for the right version of Python. I needed to use the 3.9, but the system provided the 3.8, and so there was no way to cope with that. So this is done. Now we should have all this one, all things working. Okay. So now we can run Jupyter, a simple Jupyter. That was under SA data. Okay. Okay, this one and exercise, right? Okay. And here we have non trovo un asterisco subito arrivo, sì. Should this one this one.
I think it's due to the same reason. There was no start more about. So you have an explanation with that.
This is strange because I used exactly the same version. OSJ Olive without problems.
Yes, but then we did some updates for the
Ah.
studio,
And then and then it was a mess.
yeah.
We try now.
Maybe it's already without running. Can you open and explain? So open another tab without clicking on the cell.
That's more efficient, more evident in the. What's this? The error? Soft Unicode from markup safe. Ah, this one. The problem is with Python 3.8, but this is strange. Python. There's no reason. It's a nonsense. Which I think that should be Jupyter under.
Maybe you need to install Jupyter also in the environment, because it will take Jupyter from the system.
This is strange. Or let's try this. Let's see if I install. Maybe I missed it.
Good to see they are also struggling with installation.
Yeah.
So we are not
Right. Jupyter Lab.
We are not
Yes.
alone.
That was missing.
It's not our fault.
No, this is my fault. Here, maybe I skipped or maybe because I had to find this one. This is the wrong link anyway. Anyway. Let's see if it's on with this.
And I find also with Conda, it can be very heavy. You download.
This is Mini Conda, not Anaconda. Mini Conda is more lighter. There's no R. There are no third parties, packages and stuff. It's only 70 megabytes or stuff against 3 gigabytes of Anaconda, something like
yes, but also when you install it, when all packages are installed,
sure.
that can.
But you can cope. You can if the working Python version is coherent with the system Python version, you done it. Yes, because you can install just whatever is required by your own packages. Anyway, I find the use of Conda extremely useful for contexts where you need to cope with third parties clusters. Many clusters currently for HPC work with quite ancient version of Red Hat Linux installation. I know clusters that work with Red Hat 7 and still running. And you can't find anything that is more than Python 2.7, maybe some version, maybe 2.7. And so you have to use your own version of Python, your own version of any package, or what else.
In our cluster, we
and you can't use Docker.
Because we are using Docker.
You can't when you can use Docker because the system administrator is a good man. It's nice.
Because
But
it
in
makes it a lot
general,
easier,
yeah.
then you can do.
There's a compatible, do you remember the name? Instead of Docker, you can use another container, which is,
Singularity.
yeah, Singularity, which is Docker compatible. But you need to find a system administrator that is very nice.
Because
even for that.
It's a security
Yeah,
issue.
yeah. So let's see.
Then it's smart. Singularity is smart.
Yeah.
Combine your laptop and then you support it around.
Okay, that's the right one.
And the same with Docker also.
Not again.
You need to run it in a Docker environment. Probably it's similar.
Let's
to
still this
Singularity.
fucking. Let's try it with the
Singularity,
strong-
original function.
strong solution.
Yeah, in Docker you can also, right? Yeah. So you can do Docker exit and then function. Anyway, because
Yeah.
okay,
I had to remove the 3.8 version installation. So yes, we can move this one. This one. Are you? Yeah. This is the same document within the notebook, finally. Okay. So I can also find this one. Anyway, when you run this after let's see. So if you have working Python, you can import. You can import Earth Engine. Then the first thing you have to do is authenticate. Note that he ran gcloud, which is one of the command line utility I installed before. Then you have to choose your account. Okay. Sorry for the Italian. Okay, now this is done. Authorization token. So at this point, you can run, for instance, initialize, which is part of the Python API. Of course, you need to accept again the conditions and so on, and provide password and so on, because it is expires every number of days or weeks. I don't remember exactly the limitation. And you have to repeat the operation for each box you run. So one for your laptop, one for your desktop, one for your for any platform you use. You have to provide again your credential. Eventually, the second you use the telephone even, and then this is not the end of the story, because when you run so for instance, when you run this, what's missing? There's something missing. What's missing? Oh, right. We need to restart because the authorization, I think the authorization worked after the Jupyter notebook. So let's start again. Oh. Okay, now working. No. But it's not one, no more remaining. Again, just something running under the Jupyter that is working bad.
Yeah, no.
Cache. Okay, that does not exist. There's again something wrong with the old version, because this is working. Of course. Dove sta? Su?
Apri il notebook,
Sta già aperto.
3.9,
Allora, dici qua dentro.
e vedi la Python 3.
Change kernel.
Però 3 che 3
Boh. Però.
Ah, manco OS. Cioè. No,
No, S funziona.
E vedi che
Gmap funziona.
funzione di Python style.
Facciamo ricaricare.
Anyone was using the Python API or just tell us.
Python version. Forse no. Non è sicuramente per version, infatti. Come no, sì. A parte quello che c'è scritto qua. Che cazzo? Python 3. Non c'è un tubo.
Import Python. Import Python the full version, and then print.
Mm.
Version.
Versions.
Ah, no,
Version.
version, so.
No. Non c'è una... Ma così tutto. Ah, front platform.
Ah, so. Right underscore version.
Vabbè. String forse. Facciamo
Quello senza print.
la stessa cosa.
Sì.
Version. Anche il tavolo. Mm. Non mi dai neanche completamente. Scusa, come fa questa cosa? Sì, ma questo è sempre il casino con la versione del 3.8, che a me funziona tutto, stando qua dentro, insomma.
Questo da studio che c'è creato.
Tutto casino. Allora, questa è la stessa cosa. Python version function. Sta.
Invece deve essere 3.8.
3.9.
3.9.
Run version Python, running. Che cazzo?
Go through the HTTP without running.
It's not the same. That was to change the few stuff.
No, but without running, just explain it.
Yeah, sure. Yeah. So when you use the right version of Python, not this one, and all is coherent, so not 3.8 but 3.9, you can import gmap, which is a quite new package for cope with Earth Engine, and you simply recreate by using gmap package the map object you have available within the Earth Engine environment in the JavaScript. The map object is based on IPyLeaflet. So it is a service which allow you to visualize Google Maps in this way. And you have also a tool set here. You can navigate easily because you can also have a look to the catalog, the full catalog of Google or Google Earth Engine from here, and add multiple data layers to the same map. So you have lost the JavaScript interface, but you can gain again the interface, the full interface, by using a leaflet service. That's because the Earth Engine has its own web services available for the users, what is required to do is that when you launch for the first time GMAP, this one, it asks again for having a token. The token is, you authorize this token, pass to the browser once, then it again as a token usable for a weeks. And you can use the web services available from Google Maps directly within your notebook. And you can run all those functions and have an interactive session here, fully functioning, with possibility of editing, adding polygons, adding points, adding whatever you like. And I have a lot of different functions here in the toolbox to add other data, and also view VMS and other standard web services, all overimposed to the Google Maps service. So it is more capable also in respect with the Earth Engine code editor, because you have the possibility to see also many other data, such as this one. You can mesh up with a lot of base map, this available, length cover, and so on. So it is quite more proficient for use. You can have access to user ROI. So when you edit any geometries on the canvas, this is also immediately available as a geometry within Python by using getinfo. So you get a vector, all the vector you edit within the canvas directly available to the system. And also another very nice function is this one, JS snippet to Py. Does permit you to translate from JavaScript to Python. So you can get any script from the code editor, and you can translate it into Python and run within the notebook, which is very easy and useful in many contexts. So here you see that there's complete correspondence among the API in the JavaScript world with the API in the Python world. You use also exactly the same dictionary used in JavaScript and Python, exactly the same. And the use of map with layer and all other functions does permit you to work in a very similar way. So you can use a notebook with nodes instead of using simple scripts within the code editor, which is under-documented. Currently, it's very expressive to use a notebook because you can add your own, for instance, your own paper with code. And so this is, of course, the plus of using this kind of approach to work with Earth Engine. You also have the inspector, exactly as in the code editor. You can visualize and so on. If I could fix the DAM 3.8, I can show you on fly some working script to show you the possibility of this kind of approach to use the code editor. With also, yes, you can also create, show YouTube links within the notebook and so on. So it's very it's quite more expressive than the use of the simple code editor. You can write your own web applications and so on. Of course, some kind of web application can be also realized by using here. Not here, this one, since maybe some years, or some month, I don't remember. There are now available the possibility of creating a new app within the code editor. That is a pool of scripts all organized within a workflow, which is much more near to the concept of a notebook and the possibility of creating step-by-step pool of scripts and creating a real application instead of a simple script that you modify by hand, as always, or even by using the UI interface available within the JavaScript API, which is quite limited, even if available. You know, that within the control, the code editor, you can add some UI method to create forms, for instance, and so being much more interactive with the users instead of changing parameters and data within the scripts, save the scripts and pass the scripts to someone else. You can create your own little application, your script available for a more expressive way to do things. But of course, using a notebook is much better. So with, in comparison with the use of the code editor, which is quite limited under those regards. And I don't know, I would try to fix this done 3.8 thing, because I'm like the wood. I had to try to fix this one because it's not possible that.
Why the kernel is not getting the one that you
I don't know why. There's something in the path.
That one is not a Python file, it's a mini content file.
Yes, but I'm using it by Jupyter. I'm using this one. Jupyter is this one.
Is it mini?
Yes, but there's something in the path, in the Python path, that I cannot understand.
Where it is in the source?
In the source.
Yeah. I mean, the source in the partial.
No, I changed it. I activated the new environment. Activated. I don't understand why Jupyter is using. Probably.
Can you run that line? No. Can you run this?
What?
This full line.
That one?
Yeah.
No, it's
Rather than say, yeah.
No, it's
Why?
the same. No, why? There's no reason for that. No.
Now get the same Python version.
I don't think it's that was from platform. From platform.
That was Python version.
The stupid, silly thing.
I want another day. I beat Francesco for the first time in life.
That's terrible. So, if I did this one,
Today I will celebrate.
That's ridiculous. Map.
So now open the real one, the real.
Yes. Let me open this.
So what was happening that when he was calling Jupyter Notebook, he was opening the system one
Yes.
and not the one under Unicode.
For some obscure reason, because I use the which to see what is the version of Python he should call.
So rather, in order to be
But
sure
there's
that
something,
the full path that you are sure that is under the Unicode, then you are sure that you are using the right.
Let's see again. Yeah. Python bash. Oh, right, because import. Okay, so this is right. And we see this one. It should ask for the token, but anyway, for some reason, the token is already active, probably because I called the method by Python before.
So this framework is in Leaflet.
Leaflet, yeah.
So Leaflet is another package for doing also web page, like web page. I think they mentioned to you when you were a child. Okay, so it's quite simple, but it's very light, and I use it a bit. And this one is integrated inside of this Python, so it's quite nice. Really nice language.
That was something like the drawing tools, for instance. That was this one. Let's see if work. This is the example of the. I edit a simple polygon and added a geodesic line string. So you have directly here the information. You can if you draw more lines, such as this one. This is a polygon. It returns the feature collection because it is not one single feature. Now there's a polygon and a line string. So I see the polygon, and before that I see the line string. And I can use all those to select my own region of interest, for instance. This is an example of the JS snippet to Py, which convert if all is present. Maybe there's some additional notebook extension to add, because that was here suggested, this one, installed. Sorry. One has to. There are some extensions you need to install in order to have all the extension available. So all the functionalities available, such as those suggested. So so this Gmap package get you the possibility to get back the interface, a full functional interface for the Earth engine, which is lost if you use only the standard Earth engine package, which is available via pip install simple. I find it a quite reasonable way to use the Earth engine, with also the powerness of the notebooks.
So which one you use more the JavaScript or more the Python?
This Python interface is very new. It's 2021, just last year. So it's in progress for me. It's in progress for me, not for the package. So I'm moving to use and also convince other colleagues and PhD to use Python more for this reason, because of course the JavaScript interface is much more immediate for many users and for many users. But this renders again the choice of Python the best one for most users, because you can write your own papers with code, just for the replicability of the search.
So, and of course, when you create, doesn't come to the network, it doesn't come locally.
No,
No,
it's
you
always remote.
Remote, you
So
have just a
remote.
visualization.
Yeah, yeah.
Locally, so you
Yeah.
still-
And the leaflet is local. You are not using a remote system for the web. You are using a local tile server, which use a web service from Google. So it's best for velocity. It's exactly the same approach that has now followed in some alpha stage plugin for QGIS. QGIS has exactly the same approach with some plugin, which are quite new anyway. So it's still in alpha stage, needs to be polished and so on. So it's not yet mature for full use. But it's probably another way to consume Earth Engine in a smart way instead of use the code editor. You could use the QGIS interface and process and program, and within the QGIS you can also use Python scripts with interfaces to get access to the full catalog of Earth Engine, which is powerful, very powerful. And I think I can stop here.
Okay, cool, Francesco, thank you very much.